Assalamualaikum and good day everyone. My name is Nunazira Hanis binti Nazri. So for our group project, I am responsible for tool 2 which is HWiNFO64 version 8.48. In this video, I will demonstrate how to use HWiNFO64, how to obtain the required performance metric for workload A and workload B, and finally discuss the benchmark result. Now, I will demonstrate how to use HWiNFO64 to monitor the processor during benchmark execution. First, I launch the HWiNFO64 and select sensor mode only. This mode displays real-time harvest and state information such as CPU temperature, clock frequency, CPU package power, CPU utilization, and thermal throttling status. Next, I click Start to open the sensor window. Since HWiNFO64 is a hardware monitoring tool and does not perform benchmarking by itself, I need to run it together with another benchmarking application, which is TimeBench. Before starting the benchmark, I click the Start Login button and choose the location to save the sensor log. HWiNFO64 will automatically record all the sensor readings into a CSV file while the benchmark is running. After logging has started, I launch TimeBench to execute the benchmark. When the benchmark is complete, I return back to HWiNFO to click Stop Logging. Finally, I open the recorded CSV file using Microsoft Excel. This step is very important because all the recorded sensor data is stored in CSV file. It allows me to analyze the required COA performance metric. Now, I will explain on how to obtain the performance metric for workload A. So, I do the same like I explained earlier. By then, for workload A, I run the ScienceBank multi-core benchmark while HWiNFO64 record all the sensor value. After benchmark finish, I open the generated CSV file in Microsoft Excel to analyze the recorded data. The first performance metric is thermal throttling event. From the CSV file, all recorded value remain null throughout the benchmark. This indicates that the processor never reached its thermal limit and did not reduce its performance because of overheating. The second performance metric is clock frequency delta. To calculate the clock frequency delta, I compare the processor-based clock frequency with the down clock frequency caused by thermal throttling. The formula used is base clock frequency minus down clock frequency. However, from the CSV file, I observed that no thermal throttling occurred throughout the benchmark. Therefore, the processor never reduced its operating frequency. Since the base clock frequency and down clock frequency are the same, the calculated clock frequency delta is 0 MHz. This indicates that the processor remained its normal operating frequency throughout the benchmark without any thermal downclocking. The third metric is dynamic power consumption. From the CPU package power reading record in the CSV file, the maximum power consumption was 26.787 watts, while the average power consumption was 14.2224 watts. These are the three required COA performance metrics obtained for workload A. Now, I will demonstrate on how to obtain the performance metric for workload B. So, I did the same like I explained earlier. But then, for workload B, I execute the ScienceBank single core benchmark by HWiNFO64, continue recording the sensor data. Once the benchmark is complete, I open the generated CSV file in the Microsoft Excel for analyze. The first metric is dynamic thread migration. By analyzing the CPU core utilization data, I observed that the workload initially ran on the Core 2 before being migrated to Core 4 by the Windows scheduler. It showed that the operating system dynamically moved the workload between processors' core. The second metric is localized thermal hotspot. From the individual core temperature reading in CSV file, I observed that the active CPU core consistently recorded the highest temperature than the inactive cores. For example, Core 2 reached a maximum temperature of approximately 57.4 Celsius, while Core 4 reached approximately 56.3 Celsius after the workload migrated. The inactive cores remain at the lower temperatures. This result demonstrates localized thermal hotspots where active processing cores remain hotter than another CPU cores. So, based on the result obtained from the CS analysis, the processor maintains stable performance during workload A. No thermal throttling event were detected, indicating that the cooling system was effective and the processor did not need to reduce its performance due to excessive heat. The 0 MHz clock frequency data also confirmed that the CPU maintained its operating frequency throughout the benchmark without thermal downclocking. For power consumption, the CPU package power reached a maximum of 26.787 watts with an average of 14.224 watts, showing that the processor dynamically adjusts its power usage according to the computational workload. For workload B, the analysis showed that the video migrated a single thread workload from core 2 to core 4. This dynamic thread migration help distribute processing activity across different cores, reducing heat concentration on a single core. The individual core temperature also show localized thermal hotspot because the active core always record higher temperatures than inactive core. Overall, HWiNFO64 successfully monitored the processor throughout both workloads, and by harnessing the generated CSV5, I was able to obtain and interpret all the required COA performance metrics. So that's all from me. Bye bye.